for rational functions. There are three cases that we'll be discussing, and a very easy way to solve these types of limits. All right. So this week we're looking at infinite limits of rational functions. First question you're going to ask yourself is, what is a rational function? And the answer is right there in the title. A rational function is a ratio of two functions. There'll be a function in the numerator and a function in the denominator. For our purposes, we'll be looking specifically at polynomials in the numerator and denominator. For example, if you're looking at a function that looks like x squared plus 2x plus 1 over x plus 3. We have a function on the top, our x squared plus 2x plus 1, and a function on the bottom, x plus 3. So these are the types of functions we'll be looking at, and there are three cases here. In case number 1, the degree on the bottom is larger. In case number 2, the degree on top is larger. And in case number 3, the degree of the polynomial on top and bottom is exactly the same. Now there's one word that all of these cases have in common, and that is the degree. For that, we need to go back to algebra and remind ourselves, what does the word degree mean? And the answer is, it's all about the power. The degree is the highest exponent present in the polynomial. So the degree there is the highest exponent used. In that example at the top of the page, we have x squared plus 2x plus 1 is on the top. The degree of that polynomial would be 2. How about on the bottom, x plus 3? Remember that x has a power of 1. That's the only power in the problem, so the degree is 1. In this case, we know that the degree on top is higher, so we'll tackle that problem in case number 2. For case number 1, if the degree on the bottom is larger, the limit automatically goes to 0. So let's look at an example where this would be the case. Let's find the limit as x approaches infinity of x plus 3 over x squared plus 2x plus 1. So we need to determine the degree of the top and the degree of the bottom. This will help us determine if it fits the case. The degree on top would be 1, just like we determined a few moments ago. And the degree on bottom would be 2. That means the degree on bottom is larger. So without doing any mathematics whatsoever, we can determine that this limit approaches 0. You will like finding questions like this on your AP Calculus exam because they require virtually no work. We can know just by looking at the function and checking the degrees that this limit is going to approach 0. And we're done. It's that easy. The next case is just about as easy as this one, so let's go ahead and take a look at that one. All right, in case number 2, if the degree on top is larger, then the function goes to positive or negative infinity. So let's look at an example of when the degree on top is larger. And in a few moments, we'll talk about how to know if it goes to positive or negative infinity. So let's look at an example from earlier. Let's look at the limit as x goes to infinity of x squared plus 2x plus 1 over x plus 3. All right, so we have already previously looked at the degree for both of these. We know that the degree on the top is 2. And we know that the degree on bottom is 1. So we've determined it's going to go to either positive or negative infinity. To determine if it's positive or negative, we want to look at the leading coefficient. The leading coefficient is the coefficient attached to the term with the largest exponent. In our case, this would be a positive 1. Because that coefficient is positive, the function will go to positive infinity. If that coefficient was negative, then our function would go to negative infinity. And if we were looking at the limit as x approaches negative infinity, that would be reversed. If our coefficient was negative, it would go to positive infinity. And if our coefficient was positive, it would go to negative infinity. So in our case, we have a positive exponent and a positive infinity. So we know that our limit is approaching positive infinity. This is, again, another case where very little math has to be done in order to solve the problem. You'll be very happy to see these types of questions on the AP exam. Just remember to keep your positives and negatives straight. Moving on to case 3. If the degree on top and bottom are the same, then we are going to use the leading coefficients to find the limit. This will require a little tiny bit more math, but nothing too bad. For example, let's look at the limit as x approaches infinity of 3x squared plus 5 over 2x squared minus 7. In this case, the degree on top is 2, and the degree on bottom is 2. When they're the same, we are going to take the leading coefficients and write them as a fraction. In our case, our leading coefficients are 3 on the top and 2 on the bottom. So our limit as x approaches infinity of 3x squared plus 5 over 2x squared minus 7 will equal 3 over 2. And